Hello everyone and welcome to a technical implementation showreel for the 3D game kit, also known as the Explorer, powered by Unity 2021 and Wwise 2021. This project was a collaborative effort with Marina, Guillaume, Picchi, Baptiste, Alessandrini and myself, Nicolas Roche. I'd like to thank everyone who contributed to this project. Check out the two other videos I've uploaded, one is a highlight reel and the other is the full playthrough of the game. Additionally, if you're interested in playing the game or learning more, there is a link to the itch.io page in the description where you can download the build.
The Explorer is a 3D action adventure game with a player-controlled alien, a brave protagonist exploring an alien world filled with mystery and dangers. The game combines platforming, combat, and puzzle solving, all set in a captivating sci-fi environment. Throughout the entire process, we collaborated closely using Git for source control. As it was just the two of us, we communicated directly via Discord messages and called to answer clarity and who was working on each prefab, work unit or level and to assist each other as needed. We divided our tasks so that both of us could contribute to various aspects of the game, such as ambiences and sound effects.
Before anything else, we explored the map and created a sound list. I organized it using a logical and practical naming convention that evolved over time, establishing a solid foundation for our future work. Next, we set up the Wwise session to allow us to work simultaneously without conflict. We were able to do this smoothly thanks to the preparatory work we had completed earlier. To stay organized, we structured Wwise's originals folder in a logical and consistent manner. While this may not seem essential for smaller productions like this one, it is crucial for larger projects. For this reason, we believe it is beneficial to enforce such practices to maintain an organized project archive.
By leveraging our individual interests and skills, I focused more on asset design, while Nicolas concentrated on technical aspects, including integration, QA, and debugging. That said, we both contributed to both areas to some extent.
In every level, I set up a game object called Audio Manager, which is initialized at the start of the game. It is configured to prevent it from being destroyed or reinitialized. On this same game object, I load a persistent sound bank that includes sounds for gameplay elements, LN, music and UI, as these are used across nearly every level. Each monster has its own dedicated sound bank loaded directly and associated with it. For ambient sounds, they are split between level 1 and 2 and initialized on a separate game object specifically for this purpose. These sound banks are unloaded upon destruction, ensuring that when we switch levels, the game object and its associated sound banks are removed. We design preset attenuation settings with varying parameters based on distance to ensure consistency and realism. For certain SFX and ambient sounds, I use an RTPC for elevation and azimuth to create a more realistic result and achieve a cleaner mix. These sounds also have filters applied along with a reduction in volume for added clarity. We divided the two levels between us. I was responsible for creating and implementing the ambiences for the first level, while Baptiste handled the second one. Setting up reverb proved to be quite challenging. We used the room and portal system, enabling both use game-defined aux sends and diffraction and transmission to ensure accurate sound propagation. Additionally, we configured specific settings for obstruction and occlusion. In Unity, we managed the setup by creating two layers, audio spatial and audio obstruction, with the behavior demonstrated on screen. Special thanks to Lucas Moulin for the tip. For the rooms and portals, we assigned the audio spatial layer along with properly configured components. For game objects that needed to interact with the reverb, we added the necessary components and adjusted the parameters accordingly. To ensure realistic and immersive spatial audio, I configured the system so that when a door is closed, the sound from the other side is both reduced and filtered. This was achieved by using the audio obstruction layer and attaching a child game object to the door, ensuring it moves in sync with the door's motion.
I added sound with positional automation in Wwise to bring more life to the ambiences.
Due to the slightly outdated Unity version we were using, I couldn't add the Soundline plugin directly. Instead, I created my own with the help of 2 YouTube tutorials by Kujo Sound. Props to him.
All of Helen's movements were recorded to maintain precise control over the various actions and intensities. For the footsteps, I went outdoors to record various surfaces, including dirt and grass. For the Foley, I recorded different types of clothing to capture the appropriate textures.
Water detection required a unique approach because the line trace passes through water as it is intangible. To solve this issue, I created a script and attached it to the water surfaces on the map where the player can move. The script detects when the player enters or stays in the water, setting the in-water boolean in the audio character script to true and resets it to false when the player exits, triggering the corresponding Wwise switch. Since the line trace still activates when the player's foot touches the ground, the sound is triggered accurately.
For Helen's weapon, I chose a blend of magical and synthetic elements. I started with a whoosh sound created using a synth, which allowed me to maintain control and modulate it according to the attack's intensity. To give it a sharper edge, I layered in chimes, scraping sounds, and sword impact effects.
Enhance the depth effect, I set up a depth state that decreases the overall volume and applies a low-pass filter. With our desire and need for original voice work that align with our vision, we decided to give Helen, the main character, a voice. To effectively communicate our vision to the voice actress, I created a detailed document outlining our intentions and expectations. Baptiste found and contacted Marina, an actress he had worked with previously, and arranged the voiceover recording session. I prepared a Reaper session by creating an Excel spreadsheet containing all the voice lines and proper naming conventions. This spreadsheet was then imported into Reaper to ensure a structured and efficient recording session. The voice lines, included various barks, were recorded at Slope Audio Training Studio. Baptiste took on the role of sound engineer while I acted as the art director. After the session, Baptiste cut, edited and mixed all the raw files. Using the Excel-based approach saved us time, as we were able to import everything into Wwise with the correct naming conventions. To prevent overlapping voice lines for Helen, I implemented a priority system with the following order: def, voice line, damage, move, respawn, idle and default. In Wwise, each voice-related event also triggers a stop for all voice lines with a lower priority. Each type of voice line triggers its own event function in the audio script attached to Helen. Here is how the system works. Priority check. The script first checks the current value of the integer variable via priority. If the value is higher than the one assigned to the receiving function, the process terminates without playing anything. Event execution. If the priority is valid, the script updates via priority to the function assigned value, pause the event and increment the integer variable via counter. Callback trigger. When the audio asset finishes playing, a callback event is triggered. Specific function decrements the VO counter variable to manage ongoing events. Conflict avoidance. This prevents priority conflicts, such as an idle emote sound being interrupted by a voice line, which could reset the current priority unexpectedly. Reset. If VO counter equals 0, VO priority is reset to 0, allowing all event types to be triggered.
This looks fun to smash stuff with. I will try left click on my mouse and see. I'm back.
I implemented 2 docking systems, one for Helen's voice lines to ensure clarity and comprehension, and another for the Grenadier's voice sounds for the same purpose. Both were routed to a dedicated bus equipped with a Wwise meter to monitor audio levels. The meter was connected to an RTPC output for real-time feedback. In the ambience and music buses, I linked the RTPC to control the output bus volume dynamically. This setup lowers the levels of ambience and music based on the incoming audio, creating more space in the mix and enhancing clarity.
For the enemy voice design, I recorded my own voice as a base to maintain full control over the articulation and ensure it matched the animation seamlessly. My goal was to avoid using pre-made sound banks, relying entirely on custom effects to craft the desired sound. For the jumpers, I aimed to create a character reminiscent of a dog with a cartoonish tweet that balanced being both threatening and cute. For the big jumpers, the goal was to design a much more ferocious and imposing creature. Its voice reflects its massive size and strength, delivering a sense of raw power. The Grenadier's voice combines both organic and technological elements. I utilize my voice at the base to return precise articulation, blade in lifelike expression with the cold, mechanical tone of a machine programmed to kill. This duality enhances its menacing presence while maintaining a distinct hybrid identity.
The Unity audio sliders are controlled by 3 distinct RTPCs, each managing a specific audio bus, master, music, and effect. Since the game freezes when paused, I designed an event to handle this seamlessly. The event triggers both pause all command and a state. The pause all command affects all sounds except for ambient sounds and music, ensuring continuity for these elements, while the state specifically manages the ambient and music elements to maintain immersion. All UI events are linked to the previously mentioned audio manager, ensuring centralized control and smooth integration. To ensure the music aligned with our creative vision, I created a document detailing our needs and intentions for the composer. Baptiste reached out to Guillaume Picchi, a composer and friend of his, who joined this project to bring the soundtrack to life. When a grenadier detects the player, it communicates with the player character's audio script, which then increments a variable by +1. When a grenadier dies, the counter decreases by -1. If the counter is greater than 0, enters a boss combat state and the corresponding music is triggered. If the counter equals 0, the system checks the player's currency to determine the appropriate background music. I've also accounted for the case where the player bypasses the boss. In such scenarios, the counter is reset when the player either changes levels or resets the game through the menu, ensuring the appropriate music is played for the new scene. The boss combat state always takes precedence over the standard combat state, ensuring the intensity of the music matches the gameplay. The standard combat system is divided into 2 separate logics, as chompers and splitters exhibit different behaviors. When a chomper begins chasing the player, it increments the counter by +1. When the chase ends or the chomper is defeated, the counter decreases by -1. If the counter is greater than 0, the game enters a combat state and the appropriate combat music is triggered. If the counter equals 0, the system checks the player's current scene and replays the corresponding ambient music. Since splitters don't have a built-in pursuit mechanic, I implemented an alternative solution. When a splitter triggers the shoot or trigger attack function, it sets a boolean to true, starting a timer. New splitter attacks reset the timer, ensuring each action keeps the game in a combat state. If the timer reaches 5 seconds without a new attack, the game exits the combat state and the music reverts to the non-combat theme.
And that wraps up our technical implementation showcase for the Explorer project. A huge thank you to everyone who's contributed to making this project a reality.
Feel free to leave any question or feedback in the comments below. We'd love to hear from you.